Just okay. So today I'll start a new topic, exceptions, or it's also known as exception handling. Okay, before actually we discuss about this topic, so let us try to understand why actually what is the meaning of this exception and why do we need to provide exception handling while writing the programs. See, whenever we are asked to write a program, so we have to always develop programs in such a way that they are robust and they are reliable in nature. So what do you mean by robustness of a program? See, robustness of a program, what it suggests is, whatever may be the situation your program is in, it should always run to its execution. So what it means is, whatever may be the situation, in the sense, say while you are executing your program or your program is in execution, so your program might be taking some inputs from the user. Say, for example, we will see that situation also. For example, you are asked to write a program for calculating the gross wage of a employee. Say, assume that you have employed one daily labor. So he is paid in terms of how many hours he has worked. So for example, in a week, if he works for 40 hours, say per hour, suppose just take it as some 200 rupees. Then, so what we need to do is, so how do we calculate his gross wage? So gross wage is calculated like how many hours he has worked into per hour charges. So approximately we need to pay 8,000 rupees for that employee or for that worker. So when you ask the user to enter the number of hours he has worked, say what is the input you are expecting? You are expecting some numerical value, number of hours he has worked in that week. Say if the user gives 40 in this form or in this format as a string. So can you calculate? So see, as a programmer, we should foresee the type of errors your program may encounter when it is in execution or while it is in running. So that is most important. So unless you foresee or unless you visualize all the errors your program is going to encounter during its execution, you cannot write reliable programs. Say reliable means, so if you write a program, say for example, if the user gives input like this, so now what happens? It raises an exception called value error. Value error is, it is expecting an integer but you have given a string, so it cannot retrieve a number from this string. So even though you use typecasting, it will not retrieve, it cannot retrieve a value, so it generates an exception. So what is an exception? Errors are divided into two types, static and runtime. So when you write a program, say already you know C program. When you compile, list of errors that are there in your program will be generated, listing of all the errors. So they are all known as static errors. So at the time of compilation itself, say for example, without declaring a variable, assume that you have declared ABC and you have used D in your program. So now you'll get an error saying that undeclared variable D. So that is a static error. Before compilation itself, list of errors that are there in your program. So mostly they are pertaining to the syntactical errors. So if you override the rules that are prescribed by that particular programming language, so they are known as syntactical errors. So now on the other hand, the other type of errors that may creep in into the program development, they are known as runtime errors or exceptions. So exceptions are, so now for example, all the compilation errors you have verified and you have corrected the program. So now there are no more compilation errors available in your program. So successfully it got compiled. Then what you will do, you will start executing it. So for example, in my program, assume that I have written a statement like this. X is equal to y by z. During the program execution, the value of z has become 0. So now what happens? X is equal to, assume that y is 10 and z is 0. So when the value of the denominator becomes 0, so in a division operation, if the denominator value becomes 0, so division by 0 operation is not defined by the mathematician, and same is the case with your computer. So your computer also cannot perform this operation. So now this type of error is known as exception or runtime error. So during the execution, the value of the denominator has, say, there is no syntactical error in this statement. So x is equal to y by z. So in Python, there is no syntactical error. So now you will not get any error during the compilation stage, but when you execute the program, so by chance if the denominator value becomes 0, then it leads to a runtime error. So now you will get an error message saying that division by 0 exception has occurred. So that is after compilation, whatever errors creep in into your program, they are known as runtime errors or otherwise exceptions. So in simple, runtime errors are known as exceptions. So when we write programs, as a programmer, you should foresee, say I have written 10 statements. So first statement you should visualize, okay. So when you run the program in this context, suppose if this is the input given by the user, this may lead to so and so exception, or this may lead to so and so exception. See, already without knowing much about exceptions also in first year, I think you might have done that. So whenever you ask the user to enter a file name to open, after fopen function call, what we have done, we have checked whether that function file is successfully opened or not. So if fp is equal to null, so when fopen returns null, when it is not able to open the file you have specified. If it is not able to open, how do you check? It returns a null value. Okay, I think you might, so you can remember. So then what we did, if fp is equal to null. So this is what we mean. See, before writing the program, first whenever you open a file, you need to check whether this file is successfully opened or not. So when fopen will return null, when it is not able to, say for example, if I specify xyz.txt, and if this file is not available in your current directory and if it is available in some other directory, so it raises an exception. So syntactically there is no error, but so when you are running the program, say or otherwise if you assume that you are accepting the file name from the user, by mistake if xyz file is there, and by mistake if user spells it as xyy.txt, so this file may not be present in your current directory. So when you try to open this file, so it leads to an exception. So you can check that by using this condition, fp is equal to null. So if the file fopen returns null value, it means that the file you are specifying is not available in your current directory, hence it cannot be opened, so it leads to an error. So as a programmer, so you should foresee the type of errors that may creep in or that may occur during the execution time, and you should provide what? So some alternative programming statements which will avoid your program to come out of those error conditions. Otherwise, see, for example, ultimately what is that you are trying to do? You are opening a file and then you are performing some computations. So if the file itself is not able, if your program is not able to open the file, so it cannot perform all the computations. So ultimately, so your program is not able to do what it is intended to do. So that is what we call it as not a reliable program or unreliable program. So reliable program means whatever may be the situation or whatever may be the circumstance, your program must be able to complete its execution. So it should be able to run to its completion. So that is what we mean by reliability of a program. So robustness is whatever may be the environment. So sometimes internally, so some hardware errors, some software errors, in spite of all those errors creeping in, your program must be able to give some output to the user. In the sense, say for example, if suddenly something goes wrong in the system, at least it should give the message to the user saying that because of so and so error, I am not able to run to my completion, so I am stopping here. Without that, so user is waiting for the output, but your program is in running state forever. So after 1 hour also, if it is not able to give output, then we cannot call it as a robust program. Robust is whatever may be the even in spite of some environmental errors also, it must complete its execution. So maybe if it is not able to produce correct output because of something going wrong, at least it should give a message to the user saying that because of this, I am not able to give the output. So that message, so such type of programs are said to be robust programs. So robustness and reliability are one of the most important factors that any programmer has to keep in mind while developing the programs. So in order to develop robust and reliable programs, one of the most important feature that we should make part of programming is exception handling. So what is this exception handling? So that is, see, whenever you are as a programmer, whenever we feel that or whenever we come to know that an exception is going to be raised, so as a programmer, you should provide an alternate path for your program. So providing an alternate path for your program whenever an exception occurs is known as exception handling. So you are providing and see, now for example, this statement, whenever your program compiler comes across this statement, now what happens? Z value becomes 0 means, so whenever an exception occurs, what is the normal behavior of your program? There itself the program execution stops, and otherwise the program will be terminated. So it comes out, so if there are some other statements here, they will not get executed, program counts out of the execution, it just displays a message saying that because of this exception in so and so line, so the program is halted. So that is the message you are going to see. But as a programmer, we don't want that. So whenever this exception occurs, we want to provide an alternate path. So it should come out and it should execute some other set of statements. So this is what we mean by exception handling. So whenever an exception occurs as part of the program execution, so the normal execution will be terminated. Now as a programmer, we should show an alternate path, some other code, so that user will come to know that, so because of this exception, the normal sequential execution is not possible. So we have executed a handler. That handler can handle the exception that has occurred, and it can show an alternate path of execution for your program. So this alternate path of execution, whenever an exception occurs, is known as exception handler code. Okay, so this is known as exception handling code, or in simple, exception handler. So whenever an exception occurs, so from here, so the statement which has caused the exception, after this, the remaining statements, they will not get executed. Straight away the control jumps to handling code, exception handling code, from where the execution commences. So see, first we will see some examples, and then we will write some exception handling code so that you will come to know. After that also, if you have any doubts, so you ask me, I'll try to clarify. So first, we will see some examples. Just write down. An exception is an error. An exception is an error that occurs while a program is running. While a program is running, causing the program to abruptly halt. Causing the program to abruptly halt. We can use try except statement. We can use try/except statement to gracefully handle exceptions. So just the same example which we have discussed earlier. Okay, see, for example, I'll take two variables, division by zero exception. So I'm asking the user, enter yes, no discussions, enter first number. Next, so result printing, print number 1 divided by num2 is result. So end of main function definition. So you call the main. Write down. Okay, give your attendance 65, 66, 67, 68, 69. So you just display it as invalid out. So invalid input. So by doing so, you can avoid division by 0. But so this type of erroneous input given by the user, you cannot avoid by using normal conditional statement. So value error type of statements you cannot avoid. So you have to invariably use exception. So how to use exceptions, we will see. So try except statements or try except blocks. So let us try to understand try except statements. So in C++ and Java, we will call them as try catch blocks. So there is no catch here, we call it as except. So the programming statements which are suspicious of raising exceptions, you have to enclose it in the try block or in the try. So all the statements which are suspicious, say assume that you have written a program, and in that program, so as a programmer you feel that some statements are suspicious. Suspicious in the sense they are capable of raising some exceptions, some runtime errors. So such type of statements you have to put inside the try block or try statement. So during the execution of these statements, if it raises an exception, so here you have to write except. Okay, except. Now, say for example, if this S1 raises an exception, now what happens is, generally when a statement raises an exception in normal situation, what happens? The program execution terminates. But if you write these statements within the try block, the program will not come to an abrupt end. Now the control will be transferred to except statement. So whatever statements you write here, these statements will be executed and then the program comes to an end. So when you provide a try except block, so earlier, so if you don't provide, say for example, S1 is going to raise an exception. Whenever a statement raises an exception, in normal cases, the program execution comes to an end. There itself, so and so exception has been raised, so the program terminates. But I don't want that termination. I want the program to normally complete its execution. So if that is the case, then you have to put such type of suspicious statements in the try statement or try block. So when one of the first statement or the remaining statements during their execution raises an exception, now instead of abruptly ending the program, now the control gets transferred to the except block which is associated with this try. So now in this except block, if you write some statements, these statements will be executed and then the program will come to an end. So these statements anyway, they will not get executed. So from here, the transfer controls to except block and all the statements in the except block gets executed and then so the program terminates. Now let us see some exception handling programs or programs that are provided with exception handling features. Okay. So the value error exception which we have discussed earlier, now we will see how to deal with that situation. Okay. Now this program calculates the gross pay of a employee. So calculates the gross pay of an employee. So assume that there is a daily wage worker or an employee in the organization who works on a daily wage basis. So what are the inputs that we need that we require to calculate the gross pay? As we have discussed earlier, the number of hours he has worked per week, and then so the wage per hour. So these are the two parameters that we require. Okay, let us see. So main function definition. So here we will use the try block. So because so when you are asking the user to enter input, so he may sometimes there is a chance that he may enter the input in a format which is not desired by the program. So which may raise an exception. So that's why. So I have suspicious or I am suspicious that the user input may raise some exception. So that's why I'm enclosing this part of the program in the try block or in the try statement. So try. So what is that? Hours is equal to int input enter hourly pay rate. So what is the pay rate? Hourly pay rate means per hour. So how much we need to pay for the employee or for the worker. See, for example, if worker works for 1 hour, say we need to pay around 200 rupees or 300 rupees. That value we need to give as input for this. Okay. So sorry, hours no. Enter how many hours. So we'll take another variable called pay rate. So two parameters we are accepting. Then calculate the gross pay. So gross pay is equal to, how do you calculate the product of these two? So hours into then display the result, print gross pay. Okay, maybe if you want to display rupees also, you just display rupees, gross pay rupees. So already we have calculated. So just display the value stored in the variable gross pay. Now if you want to display it in the correct format, maybe you can write, so format. Okay, so what is the name of the variable? Gross pay. Then and then separator is equal to, so you can also, so instead of this, so better to write like this, format. What is the variable value that you want to display? Gross pay. So I want to have only 2 decimal digits after the decimal point. Okay, so separator is blank. So if you want, you can write that or just display the value of the variable. Now you see under this, so what is the type of the exception that we are expecting these statements to raise? So value error. Why we have to write? I'll try to explain. V and E are capitals. So print. So just we are displaying a message. Error in input. Okay. Now, first run one. So assume that there are no compilation errors in this program. So it got successfully compiled. Now when you run this program, okay, first it will ask how many hours. So assume that the user has given the number of hours as 20. And then it will ask enter hourly charges. So hourly charges, suppose if it is given as 400. Then it will calculate hours into pay rate. What is this? 20 into 400 is, so gross pay will become how much? 8,000 rupees will be stored in this gross pay variable. Now there are no errors, so you'll see the output like gross pay rupees 8,000. That value you'll see. Now again, when you run the same program, run 2. So suppose hours, so he thought that it should be given in as a string, so he will give it as 20. Now 20, when you give as input to this int function, so the string that is given as input for this string should contain a numerical value. Then only the string will retrieve the numerical value. But here if you see, there is no numerical value, it consists of only set of characters. So there is no numerical value embedded in this. So this will result, this int when you run, when you give this string 20 as input, so it cannot retrieve a numerical value. So it raises an exception known as value error. In normal cases, if you don't use the try block, so here this program will abruptly end. It will terminate, or it is going to terminate. But now I don't want the termination to take place. I want to handle the error in a different way. Now instead of abruptly ending this program, so inside the try block, if you write a statement which is capable of raising some exception, now the control transfers to except block or except statement. From here the control transfers here. Now value error. So what is the type of exception that has been raised? Value error. So it will come here. So value error. So it will display this statement. Error in input, not valid numbers. So the error, what is the error? User has not given the valid number as input. Hence, this program has encountered error. That's what we are trying to display to the user. And then the program normally completes its execution. It's not going to end. See, this is a very small program. You may not understand the importance. But see, assume that there are some server programs. So server programs in the sense, your ATM server program. So as a user or as a customer of a bank, assume that you have a valid ATM card. So you'll enter into the ATM machine kiosk, you'll insert the card, you'll enter the valid PIN number, then it will ask, enter some amount that you want to maybe withdraw from the ATM machine. So for example, if you don't enter a valid number, so instead of 4,000 or 8,000, if you enter some other a non-numerical value, so what happens? Say if your server program, so if it encounters an exception and if it stops working, so what happens? As a user, you will not get any input. So you'll keep on waiting. So you'll not know what is the situation. So if the server program abruptly ends, so that because you have raised an exception or your input has raised exception, so it should not end. So it should run for all the 24/7 by 365. So such type of reliable programs are robust programs. So whenever it encounters an exception, it should come out of that exception condition and then it should normally run. So that is what we are showing. So whenever an exception occurs, so this is the alternate path the program has to follow. That is what you have to show to your program as a programmer. Otherwise, it abruptly ends and user cannot see any output henceforth or henceafter. So that type of situation we should avoid. When you write reliable programs, so reliable programs, whenever it encounters an exceptional situation, It should come out of that and it should take an alternate path of execution. So that is what the alternate path of execution you have to show whenever you foresee an exceptional situation. So what is the alternate path your program has to take? That alternate path we have to show to the program. So that is known as exception handler. Why we have to write this value error? So I'll try to explain in a moment. So sometimes the same set of statements may raise multiple exceptions. They are capable of raising multiple exceptions. Say value error, or another error is IO error. So input output error, I'll try to explain the purpose. So suppose if that type of error is raised, so you can write another set of except block. So say for example, this is except 1 and you can also write except 2. So when one type of exception is occurred, this is the handling code. When two type of exception is raised, this is the code that it has to execute. Like this, you can handle or you can write exception handlers for multiple exceptions simultaneously. So when one type of exception is raised, so this is the handling code. When two type of exception is raised, this is the handling code. Like this, the same try block can have multiple except statements or multiple except blocks. So that is the advantage. By naming the exception, you can provide multiple exception handlers. So we will see those examples also. So if you have any doubts, you please ask. Watch. Watch చూడకూడదా? Okay. Now let us see another example which is related to files. Let's write down this program. Say you are trying to, this is a simple or a small program in Python which accepts a file name from the user. So user is supposed to give an existing file name as input to this program. Now what this program does is it opens that file in the read mode. So and then after opening the file in the read mode, the content of that file will be read and it will be displayed. So for example, if you have created a file with all the 60 students names and then information of your classmates, so it will open that file and it will display the information about all the students. So that is the purpose of this file. Okay. So here file name is equal to, so I'm asking the user to enter the file name that user wants to open. So now I'm writing the next set of code in the try statement or try block. Okay. Now you can see so this is the file variable is equal to open. So already the file name has been stored in a variable called file name. So you should not enclose this file name in the single quotes because this is a variable name which holds the file name to be opened. So in which mode I have to open this? In read mode. Next. So we have to read the content of this file and then display it. So is equal to in file. So if I want to read line by line, I have to use read line. If I want to read the entire content of the file, I have to use read function call. Already we have seen. So read will return the entire content of the file and that will be stored in a string variable called contents. So after this, what we need to do? Print contents and then close the file. So in file close. Now let us write the except statement. Now what is the type of the error? So here the error is known as IO error. So what is this IO error? I'll try to explain. So here also we are going to deal with an exception which is known as IO error. Now for example, so we are asking the user to enter a file name. So assume that already user has created a file called students.txt and he has stored all the information about his classmates in that file. So if he correctly gives the name of this file, so in this in file variable, this is the name of the variable. Sorry, what is the name? Sorry, file name. File name. So this is the name of the variable in which we have stored students.text string. So this string holds the name of the file to be opened. User wants to open. Now you see open file name. What is the value stored in this file name? Student.text. So if this file name, that is with this name, if already a file exists in your current working directory, so that file will be opened in read mode. The entire content of that file will be read by using this read function, and then it will be stored in a string variable called contents. Then we are displaying the contents. That is, the entire content of that file will be displayed. Now for example, instead of this file name, assume that user forgets to give, it's actually students.txt, but user gives it as only tx. Does this file exist in the current working directory? No, it does not exist. Now, when you try to open a file which is not existing in your current working directory, it raises an exception called IO error. So, when user is trying to open a file which is not existing in read mode, say if you give in write mode, it does not make any difference. A new file will be created. It does not result in any IO error. But if user specifies a file name, and if he is trying to open it in read mode, a non-existing file in read mode, so it raises an exception called IO error. So immediately when the user specifies a wrong file name which is not existing in the current working directory, now IO error exception will be raised. So from the try block, the statement which has raised the exception, so after this all the remaining statements will not get executed. So directly the control jumps to except block. Now IO error. So here we are just displaying the message. Trying to open a non-existing file. This is the message we are giving to the user, so that user will know why the program has come to an end. So we are telling the user that you are trying to open a non-existing file in read mode. That's why an exception has occurred, and this is the end of the program. So normally the program ends. It will not end abnormally or abruptly. So from try block, the transfer comes to the except block, and here whatever statements you have written, those statements will be executed, and normally the program terminates. So we are showing an alternate path of execution for your program when an exception occurs. So that alternate path is known as exception handling code. Okay. And that exception handling code we need to write in the except statement. The statements which are suspicious of raising exceptions, you have to write them in try block. So whenever an exception is raised, the remaining statements in the try block, they won't get executed. The control jumps to except block. So that is what you have to understand. Okay. So if you draw a flow chart, it looks like this. When the statements inside the try block are getting executed, and one of the statement, when it raises an exception, so the control transfers to the respective except block. When there is no exception, so try block will be executed. The remaining statements after the in the try block will be executed. Okay. Now suppose if it doesn't raise exception, so all the statements will be executed in sequence, and except whatever statements you have written in the except block, they won't get executed. Okay. Whereas here, when an exception is raised by one of the statements that you have enclosed in the try block, so the control jumps to except block. The remaining statements, they won't get executed. So you should know the behavior of try and except blocks, how they are going to execute. So in order to avoid what we call as abnormal execution of the program, we are using these try and except blocks. So we will see some more programs related to exceptions. So handling multiple exceptions, all those things in the next class.